So the session is being recorded right now. Okay, the first section, we're going to learn how to use collected data to construct what we call a frequency distribution table. And what I'm going to do, the first page is a summary of the first three sections, so I don't need it, just at the moment. So I'm going to go, to the first example that you have right here. It says that the Marsh utility bills and dollars of 30 homeowners are listed below. Construct a frequency distribution table, which I'm going to explain to you what we mean by constructing a table. To construct a table, we need to organize the data that you have here. These are the bills in dollars per month. And we need to display them in a way, just that they will look nice and easy to display and represent. And one way, just to display data, it's called a frequency distribution table. I'm going to show you one way to do that and tell me if you think this is a proper way, just of doing it. And tell me, why do you think this is a good display or not a good display? This is what we can do. We can figure out, the different amounts of bills here, like the lowest amount is $33. Then we put 34, then we put 35, 36, up to the highest amount, 50. And then we see how many bills are $33. Let's say there is one bill, let's say there's two, there's one bill, let's say two bills, etc. Do you think this would be a good display for people to look at and understand? What's not good about this display?
Too large.
Yeah, it's too many. I wouldn't want to look at table, guys, that has 17 or 18 rows. Look. Nobody wants to look at this. And it's very difficult, just to understand and follow. And you have to keep looking up and down, just to get answers. So there must be a better way, just of doing this. Rather than putting each bill separately here and see how many households paid $33, how many households paid 34, how many paid 35, we can put them in groups and we can make the table smaller. The lesser the number of rows, guys, the better and the easier, just it is to understand, just and even be able, to visualize the table. So here's what we're gonna do. He's telling us display this data in a table, use 6 classes. 6 classes, guys, means 6 rows. So I only gonna use 1, 2, 3, 4, 5, 6 rows to construct the table. And I'm gonna show you how to construct the table when he tell me how many rows you have to do that. Once he tell me how many rows, then there is only one way to do it, and all students will have to do it exactly the same way. So look how the process begins. You figure out the lowest value first, and then the largest value. What is the lowest value here that we have? It is
33.
33. And the largest value, I believe it's 50. Then you subtract largest minus lowest, which is what? This is the process that you're going to do to construct tables, which is 17. Then you take the largest value minus lowest value and divide it by the number of classes, which is 17 divided by 6. Can someone tell me what 17 divided by 6 is?
2.8.
2.8. You need to round it.
Rounded. Yeah.
You need to round it to the round it up to the nearest whole number. So that rounds up to what?
3.
To 3. This is the magic number, guys. You need to do this in order to construct a table. When you go and do your homework online later, when he asks you to do that table, you really need this number. Once you figured out this number, guys, you're going to see how easy it is to construct the table. So this is called the class width. This is called the width of the interval. From to, the width of each row of each amount here, the interval. An interval means a range of values from one value to another value. And that number decides, just the width or the length, just of this interval. It's going to be 3. Even if you guys got 2.1, you don't round it to 2, you round it up to 3. Always round up. As you see the word here, I didn't say rounds, I say rounds up to 3. Now watch and see how we're going to construct the table. You put the lowest value here, 33. So the first step, guys, is to do this work. The second step is just put the lowest value, 33. And now watch. Start adding 3 this way. Plus 3. Down. So that will be what? 36. Let's add another 3. 39. Add another 3 this way. 42. Add another 3. 45. Add another 3. 48. Any guesses? What do you think the value here should be? From 33 to what?
35.
Exactly, because it's the value immediately before 36. You got it. And add 3, guys, exactly the same way. 38. 41. Don't worry, it's going to cover the 50. We're going to get to 50. Even sometimes we go beyond 50. That's fine. And look. These are called classes. I have 6 classes. These are intervals. All the values between 33 and 35 inclusive. All the values between 36 and 38 inclusive, excuse me. No overlapping, as you can see. This one ends with 35. That one starts with the 36. So there is no overlapping in the classes. So now we fulfilled, just what the requirements of this question is, that he wanted 6 classes. I was able, just to get 6 classes.
Sorry, I
Now,
have.
yes, go ahead.
For the rounds up to 3, that's mean whatever number we got, like 1.2, 1.5, we rounds up to 3.
No, 1.5 goes to 2, to the next whole number.
Oh, okay. So we just rounds up.
It just rounds up. Let's say if you get 7, let's say you get 7.05, it goes to 8. You don't go down, you just go all the way up.
7.05 goes to 8.
Yes.
Okay, and the other question is why you pick the 35? In the table?
Because what would be the value immediately before 36 here?
So we always pick the value before the second row?
Exactly.
Okay, thank you.
Exactly.
Mr. Bazzi,
Mm-hmm.
you see how you added +3 to all of them?
Mm-hmm.
Did you get that because when we rounded up it was 3? Is that why it says +3?
Exactly.
Okay.
That's the only
Okay, I just
reason.
wanted to make sure. Okay.
Yeah, you're 100% correct. You're 100% correct. Exactly. That's how you construct the table. Okay, tally, I think you're familiar with it, guys. It doesn't need to be here, but I'm just going to do tally for the first time. See how many values in the data set are between 33 and 35. So let's help me, guys. That's 1. That's a 2. That's a 3. You do this. And if I make a mistake, just let me know. Between 36 and 38. 1, 2, 3, 4, 5. Did I miss anything?
38, the second one.
Oh, see, I did. So look, this is how you do tally. 1, 2, 3, 4, 5, and then 1. Okay, next one. 39 to 41 inclusive. 41, 39, that's a 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and then 6. Again, that's not required. We don't need it if you just counted. We're gonna put it here, but let me just finish it since I started it. 42 to 44, guys. 1, 2, 3, 4, 5, and 6. Oh, it's all 6s here. The way we do tally, we do 1, 2, 3, 4, and then 5, each 5 together. 45 to 47 inclusive. So 45 to 47, 1, 2, 3. Okay, so I got 6 and 6 and 6, 18 and 6, 24. There must be 6 at the very end. Let's see. 1, 2, 3, 4, 5, 6. We're correct. Okay. Let me tell you what frequency means here. Frequency means how many values are there between 33 and 35 inclusive. There are 3. And a 6, and a 6, and a 6, and a 3, and a 6. And you guys, you should make sure that your sum of all the frequencies should add up to 30, because I have 30 values. If you don't get 30 values, that means you've made a mistake somewhere. So up to here, guys, you completed the table. This is called the frequency distribution table. And now I can ask you a lot of questions about this table. If I ask you guys how many bills were there between, how many bills were over $44, for example, can you answer this question? Don't look at this anymore. You don't need it.
9, right?
Bills were over $44.
9.
9, exactly, because from 45 to 47 and from 48 to 50, these are over 44. 3 plus 6, 9, exactly. How many bills were between $36 and $38 inclusive of 36 and 38?
6.
6, you can answer. You can answer a lot of questions when you have the table. It's displayed nicely. The only thing that you can answer, if I tell you how many bills were exactly $37, you wouldn't be able to tell if you don't have the actual data. So, but that's a summary of the table. It's nicely organized in here. And this is called the frequency distribution table. You need 2 columns. The first column is called for the class. It's the amount. This is called the class. Or the interval, they call it in statistics class, and this is the frequency. You just need 2 columns. You really don't need the tally, but you can always use the tally to help you count. That's all. So now let me tell you what a relative frequency is. So let's just reveal this. Relative frequency means the 3 is what fraction out of the total. How many do we have a total? I have 30 bills. So relative frequency means the 3 out of 30. You just divide the 3 by 30, guys.
Right.
Which is 0.1. This one will be 6 out of 30. So for relative frequency, guys, you do nothing but take frequencies and divide each one by the total. That's a 0.2, that's a 0.2, that's a 0.1, 0.2. If I ask you a question, guys, without doing any math, if you add up all the relative frequencies, what should they add up to?
1, right?
1, exactly, 100%. 100%, they should add up to 1. They should add up to 30 divided by 30. All right. This number, guys, here, the beginning of the class, it's called the lower class limit. And I think, guys, you know what this one is going to be called. This is called the upper class limit. One question you might see in the homework, he'll give you a table and he'll ask you, what is the lower class limit for the third class? So you just go 1, 2, 3. The lower class limit for the third class is 39. And the upper class limit is 41 for the third class. And this has 1, 2, 3, 4, 5, 6 classes. Okay. Any questions about the frequency distribution table, guys? We're going to do some more practice, but just to give you a feel how that works. That is how you construct a frequency distribution table. Now, there could be some question, guys, where he gives you the table and he'll ask you questions. You don't need to construct it. For example, here's a table. I'm going to just come up with some questions here. So this is the class, and this is the frequency, F, let's say from 0 to 7, from 8 to 15, and from 16 to 23, 5, 7, 10. Okay, that's a table. This table has 3 classes. If I ask you what's the lower class limit for the second class, you tell me it's 8. What's the upper class limit? You tell me it's 15. But I'm doing this to ask you this question. What's the class width?
It's 7, right?
7. I expected someone who's going to say 7, but it's not 7.
Is it 0?
But you went this way. But remember how I did the class width? I did it this way.
Oh, yeah. So 8.
8.
Yeah.
Exactly. You subtract, guys, you take the first lower class limit, the next consecutive one, and you subtract them. Look, 8 take away 0 is 8. 16 take away 8 is 8. You can do it this way as well, guys. 23 minus 15 is 8. 15 minus 7 is 8. But the only thing I don't want you to don't go horizontally. You go vertically when you do the class width. If you go horizontally, you will miss by 1. You can go horizontally, guys, but add 1 to your answer if you do that. Because how many values are there between 0 and 7, inclusive of 0 and 7? Actually, if I count them, guys, there will be 8, not 7. Watch. 0, 1, 2, 3, 4, 5, 6, 7. Count them for me. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 values. That's why, to be on the safe side, subtract any 2 consecutive lower class limits or any 2 consecutive upper class limits to find the class width. All right. So I'm going to write a note here. If you have a frequency table, to find the class width, simply subtract any 2 consecutive lower class limits or upper, it doesn't matter. That's how you find the class width. All right. Any questions, guys? Yeah, Elizabeth said 8. Okay, let's do number 2. A sample of 15 Boy Scouts was selected and their weights in pounds were recorded as follow. Using a class width of 10, give the upper and lower limits for 5 classes. So he's telling us what the class width here. We're not asking you to find it. He's telling us that it is 10. So let's see how we're going to do that. Okay, let's do it. Using a class width of 10, give the upper and lower limit for 5 classes, starting with the lower limit of 95. He's also asking us not to start with 97, which is the lowest value. He wants us to start with 95. So I'm going to put the 95 right here. Okay, can you guys help me out now? How do I do the rest? Plus what? 10. Okay. Now you might tell me, Mr. Bazzi, you just said you start with the lowest value. Yes, but here he says, I want you to start with 95. That's a direction. We should have started with 97, but he says start just 2 units before. That's fine. So that will be 105, guys. Plus 10. 115. Plus 10. 125. Okay, can you guys tell me what the value is going to be here? It will be the one immediately before 105. So that's
104.
104. And do the same thing, guys. Add 10. 144. And that's fine. So that's part A. That's how wants part A, but I'm going to do the whole thing at once. Okay, frequency, just let's count how many values are there between 95 and 104. So I got 1, 2, 3. Oh no, just 100, sorry. Just 2.
2.
Okay. Between 105 and 114, so I got 110. 106, 2, and 108, 3. 115 and 124, guys. That's 124, 117, 3, 4, 5. Just correct me if I make a mistake. 125 to 134. 1, 2, 3, and I think the rest are these 2. All right. And they add up to 15, so that is correct. That is the frequency distribution table, guys. As you can see, it's not difficult. If you just know what you're doing, just follow steps, and you should be able to get it done. If he asks you to do a relative frequency, guys, you just add another column here and just take 2 divided by 15, 3 divided by 15, 5 divided by 15, and so on and so forth. Okay, now we're going to do the next one. He gives you the table. He wants you to do a relative frequency distribution. So you already have the class here. You do have the frequency. We're just going to add a relative frequency. And let me just move this a little bit so you can see that. So relative frequency means pretty much a percent or a fraction out of the total. Right. So we need the total, guys, here. So you can do the sum of the frequency. By the way, this notation, guys, means sum, total. F frequencies, so sum of frequencies equal. You just add them up. 13, 25, and what?
49.
49. So for this one, it will be 5 over 49. Probably a question you'll ask me, do we need to divide? If he says round your answer to 2 decimal places, you must do that. If he doesn't and accept a fraction, you just leave it like this. And that's it. That concludes the question. I think we can do. I just made a mistake, still thinking 2020 here. Change this to 2021. right. You're going to learn about histograms now. If you've seen a histogram or a bar graph, a histogram is just pretty much, like a bar graphs, but the bars are connected. So they touch each other. And I'm going to show you how to construct a histogram by hand. This is probably one of few graphs where you learn how to do them by hand, but the rest of them are just, we'll use technology mainly. You don't have to worry about them. But the histogram is kind of important to us. You need to know how to construct this by hand. You already have the frequency distribution table, and we can use it to construct the histogram. Okay, you have two axes. From beginning algebra, guys, you learned that this is a coordinate system. This is the x-axis, and this is the y-axis. For your information, the x-axis is the class, and the y-axis is the frequency. So here you can put the weight. And here you can put the frequency. Okay. The next step, you need to scale the vertical line, not the horizontal line. Don't worry about the horizontal line, the vertical. I need to go as high as 15. So I need to scale this up to 15. What do you suggest? How many tick marks should we put in here to get to 15?
5s.
Okay, 5s would do it. You can do 3s as well. You want to do... I'm going to just do 3, so I'll give you a little bit more, but 5s would do it, as long as you are consistent, guys. If I ask you to do anything by hand, I give you a grid, so we'll make it easy for you to... If you do 5s, you then do 5, 10, 15. That's fine. Okay, very good. So we got the frequency line ready, and now I'm going to show you how to do the histogram where the bars are connected. Okay, the first one is from 135 to 139, and it has a frequency of 6. So watch, I'm going to start. You can start anywhere you want. I'm going to start here. So I'm just going to go up to 6. That's my first bar. Second one is 4. So I'm going to go a little bit higher than 3 right here, guys. And you make sure the width is very much the same. Why the width should be the same, guys? Can you argue that? Why?
Because the width of the class is 5.
Exactly, because the classes all have the same width. Excellent point. 11. Just go a little bit below 12, guys. I mean, you're not going to be perfect here, but... That's 11. Then 15. I have to go a little bit higher, up to 15. And then 8. 8 is below 9. That's an 8. Okay, now I need to label this. I'm not going to label it, guys, from 135 to 139. That's going to be too busy, too crowded here to read it. So I'm going to have to be creative, figure out, just a nice way, just to label the bars. So look what we're going to do. We're going to find the midpoint between 135 and 139 and put it right here. The middle. Just one number. So what would be halfway between 135 and 139, guys?
137.
And how did you know that?
Added both and divided by 2.
Divide by 2, exactly. What would it be for the next one? 142.
142.
And actually, guys, you don't need to look here to figure it out. What would be the next one?
147.
147.
And how do you know that?
At 5.
Why do we add 5? Because this is the class width, isn't it?
For the whole class, yeah.
Yeah, plus 5. You see, guys, once you figure out the class width, it's consistent. Okay. Have you seen something like that in a graph, guys, before? When you see a symbol like this, it's telling you that we did not start at 0. We did not, I started anywhere I wanted. I just moved a little bit to the right. So when you see this, this is a good thing that they're trying to alert you that we did not begin at 0. We're not scaling from 0 here. You just start anywhere you want. So that's simple. And this is your histogram, guys. That is, that's what we call histogram. These are called the midpoints. Okay, but one question I want to ask you here. Is there a gap between the first class and the second class? Do you see the gap? Where does this one end? At 139. Where does this one start? At 140.
140.
So there is a gap between from 139 to 140. But the way I constructed the histogram, the bars, there was no gap. So do you guys have any idea how the software compensate for that? If you go to Excel and tell Excel, construct a histogram for me, Excel will know that it has to take care of the gap and eliminate the gap. Do you guys have any idea? You don't have to know it, but if it happens that you know, how did we eliminate the gap? I mean, there should be a gap of 1. There should be a space between the 2 bars. But I managed, just not to put any space, and I connected the bars together. And there is a reason for that, something that the software will do in the background to get rid of this. Do you have any idea?
Do you eliminate 140 and just start from 139 and so on?
You can't do that. You cannot do that because there is a 140 here. Look what happens. Here's how the software will compensate, just for this. What is the difference between 139 and 140?
1.
This one is the gap. The lower class limit and the upper class limit will argue who's gonna compensate for the 1. Well, they reach a compromise. We will deduct a half from here, from the lower class limit, and we'll add a half to the upper class limit. And let me show you what happens if you do this. So we split up the 1 into 2 pieces. A half will get deducted from here and a half will get added there. It's just like you did nothing. When you take it from one side and you give to the other side, it's just like you did nothing. So look what happens here. This will become, the 135 will become 134 and a half, and this will become 139 and a half. Okay, can you guys tell me what's gonna happen in the second class? Subtract the half, so this will become what? 139 and a half. And what happened to the other one? 144 and a half. 144 and a half. And then you just add 1 here, 149 and a half. Did you notice, guys, that there is no gap anymore? We took care of the gap, and this is how the software does it. It just, the software will find whatever the difference is between the end here and the beginning there and split it up between the 2, the lower class limit and the upper class limit, in order, just to come up with what we did right here. So no more gaps. But this is something in the background, guys, you don't have to worry about. But I just thought to explain it to you, that how the gap is taken care of. It's all done automatically for you. Even when you use Excel, it will do it automatically. It will ask you, do you want gaps or no gaps? You just say no gaps, and then Excel will do exactly this, and then will display the graph. So what's the difference between a bar chart and a histogram? For your information, guys, a bar chart looks like this. The bars are not connected, so probably now you can answer this question. The bars in a bar chart are all the same width, while the bars of the histogram may be various width. No, that's not true. Can you guys look and tell me which one is going to be the true one?
B.
The bars in a bar chart may be of various width, while the bars of a histogram are all the same. No, the bars even in the in a bar chart should be not just of the same width.
Is it C?
Yep. The bars on a bar chart do not touch, while the bars of a histogram do touch. Exactly. All right. And we're gonna, guys, demonstrate one more example of histograms. Construct a frequency polygon for the data. So, and let me tell you what a polygon is. Before we do that, I'm just gonna do a histogram first. So let's say construct a frequency histogram first, and then polygon. Because for the polygon, which I will explain in a minute, you just need a histogram. It will make it a lot easier. Okay, we need to scale here, guys. So I need to go up to 13. Look what I'm gonna do. I'm gonna do a 2, a 4, a 6, an 8, a 10, a 12, a 14. I think that's enough. Okay. First one, 50 to 52 is about 5. Okay, let's see what a 5 is. We'll be halfway here. That's a 5. Next one is 8. We're just gonna go to 8. Then 12. Then 13. Just go a little bit higher. And then 11, a little bit below 12. Okay. And here, guys, you need the midpoints to make it easier. This is called the frequency. This is called the height. And this is the frequency. And the midpoint between 50 and 52 is 51. And all I need, guys, is just to figure out the class width, which is 3, as you can see, and just add 3 here. As simple as put the break here that we didn't start at 0. And now let me show you how to construct a frequency polygon. I'm going to use black ink. Okay, you mark the beginning of the first histogram. Let's put an X here. And you mark the end of the last bar right here. And then you mark the top middle of each bar. Okay, then you start from the beginning of the first bar and then draw a line like this. Then from the second to the third, you draw a line. Straight line, straight line, straight line. And then from this one all the way to the end, you just draw another line, sorry. And that would be your polygon graph. The reason why I did a histogram, because it's very easy to construct it when you have the histogram. Just mark the very beginning of the bars, the very end, and the top middle of each bar and just connect them with lines. I got 1, 2, 3, 4, 5, 6 lines in here. Any questions about polygon graphs? All right. And one more thing I would like to mention before we wrap this section up. Okay. This is like the 135 and the 139, I call it lower class limit, upper class limit. When you subtract the half and add the half, this will be called the lower class boundary and the upper class boundary. So boundaries for the histogram, but limit for the frequency distribution table. So this is called upper class boundary. Here, upper class limit. Okay. And that concludes section 2.1, guys. That's pretty much you need to know in this section is how to construct a frequency distribution table and how to construct mainly a histogram. Do you have any questions for me?
I think I missed what you were saying about the upper class boundary. Does that have to do with it being like 0.5?
Exactly. When you subtract the 0.5 from the left and add the 0.5 to the right, what you have are not called upper and lower class limits anymore. They call them upper class boundaries and lower class boundaries.
Thank you.
They just changed the name. And that's all right. The next section is very easy one. And I mean easy. Stem and leaf plot. That's the only thing in section 2.2 that you need to know. There are so many other graphs, pie graphs, line graph, time series graph, Pareto chart. You don't have to worry about them. You just need to learn how to construct a stem and leaf plot, and which I'm going to show you right now. Okay. Well, stem and leaf, guys, it explains itself. So you need to draw something that has a stem and a leaf. Well, there should be a divider between the stem and a leaf. So that's a divider right here. And I'm going to put the stem here and the leaf there. Okay, guys, take this number 44. If you want to split it up to a stem and a leaf, what would you split it up to? What's logical way to split it up?
22 and 22.
No, just the digits that you already have. How many ones do I have in 44? I have 4 ones, right? And how many tens? 4 tens. If you go to 38, I have 8 ones and 3 tens. Look what we're going to do, guys. We're going to make the leaf the single digits, the ones, and we're going to make the stem the tens. That's it. So how many tens do we have in those numbers? I have one number has 4 tens, one has 3 tens, one has 5. Do we have anything else? Anything that has 2 tens? No, it seems like 3 or 4 or 5 only. So look what you do here. You just put a 3, a 4, and a 5. Now let's go to the leaves. If you had a 27 here, then you would put a 2 before the 3, but I don't see. I only see 3s, 3 tens, 4 tens, and 5 tens. Now the leaf. Okay, for the 3, I have an 8. So I'm going to put an 8 here. I have a 6. I have another 6. I have a 5. I have a 7. I have a 9 and an 8. We're not done yet. I have a 6. I have a 5. And I have a 3. 4. That's a 4. A 1. A 3. A 2. A 9. 8. A 0. A 1. A 3. Try to allow 0, 1, 3. 5 and 5. Oh, I'm running out of room here. And 1 and 7. 7. Then I have 0, 2, 3, 4. 0,
2, 3, 8.
2 and 3 and 4. And I'm running out of space here. I could have put another 4 here, but assuming that I have, okay, I'm gonna squeeze him somewhere else.
I
2,
think it's an 8, not 4.
an 8, yeah. 2, 3, 8. I can put him anywhere I want. That's an 8 here. And then the 5s. 0, 0, and 0. All right. Now we have what we call it's not a complete stem and leaf plot before you make it. So if someone look at this, they're not going to make any sense out of it. So you guys, you have to put a direction for someone to be able to read this one. What would you constructed this one and you want anyone who doesn't know statistics to be able to visualize this and understand it. What kind of information would you give him to be able to read it? If someone have no idea about what this one is, you need to provide them a hint on how to read, this graph. What would be the hint?
That the stem is like the 10 digits.
Okay. You do
And
that.
then
Yeah. You put a key. They call it a legend key. In Excel, they call it a legend key. You put the 3 like this, and you put the vertical line 8, and you tell the reader that 3 vertical line 8 means 38. You don't have to do the 3, 8. You can do any one of those guys, like 5/0 means 50. Now a reader will understand, just how to read, the stem and leaf plot. So this 38, 36, 36, 35, and so on, and so forth. Given this stem and leaf plot, if I ask you guys, what was the most common bill? What would you say? What was the most common amount, just for the March utility bill? Would you agree with me if I say it's in the 40s? Because it seems like this is the largest, just one right here. And what was the least common bill? That would be in the 50s, because there's
50s.
only 3. Yeah, it seems like 4 is the dominant in the 40s. Most people will pay 40 something, then 30 something, and then very few will pay $50. And that's something from the past, guys. You know that we pay a lot more than 50 or 40 or 30 nowadays. That used to be probably 20 years ago. So this is what a stem and leaf plot is. If I give you another example, guys, if you can help me just do that. I'm gonna put a few number and then tell me how you construct a stem and leaf. Okay. We need a stem and leaf plot for this data set. You really don't need to put the stem. You don't need to write the word stem and leaf. You just can do the vertical line. How many digits are gonna go to your stem, guys?
2.
2 digits, definitely. The 10s and the 100s. So these 2 will go to the stem. but you don't repeat them. They're already. So I need a 1, 0, I need a 1, 1, and I need 1, 2. And now, guys, let's figure out what the leaves are. That's a 0. That's a 7. That's a 6.
Was the first one supposed to be a 0 under the 11 and not the 12?
Oh, yeah, you're right. Okay, you know what? Just to make it work, I'm going to add 100 here so I don't mess up what I did. So we already have the 0, the 7, the 6, then that's another 7, then another 9, and a 2. 11, that's a 0. Okay, that's a 7. Align them nicely. We're going to align them, try to align them here. 15, 5, and then 7. And then the 12, I got a 1, I got a 0, I got a 3, and a 5. And then you have to put the key here. You tell the reader 10/0 means 100. That's very important. And now you have complete stem and leaf plot, guys. So if probably you would ask me, do we need to reorder those numbers? You can make them 0135, 0577, or 026779, but that's unordered stem and leaf plot. Okay, and I'm going to show you in a little bit how StaticCrunch can do a stem and leaf plot for you. The TI-84 doesn't do it, but StaticCrunch can. All right. Talking about misleading graphs, I would like you guys to look at those graphs and tell me what's misleading about them. So someone is making a claim that their sales were doubled. So they had a 2x2, and to justify their claim, they said, well, if the sales are doubled, so this one doubled, so it's a 4x4 now. But this is misleading to the viewer. What's misleading about this graph? So the claim is the volume of our sales has doubled. What's wrong with the display? Does it show that the volume has doubled here, going from here to there? What they did, the length was 2 and the width was 2, so they doubled the length. That's a 4, it became a 4x4, but that's very misleading, guys.
Because it looks like it quadrupled.
That's right. Why? You are correct. That's a quadrupled. I have 4 boxes here. Now I have 16. That's misleading. But the person who did this, he said, well, I'm doubling the length and I'm doubling the width because the volume of sales has doubled. But you cannot just double both the length and the width, because that's going to impact, the whole thing and make it 4 times as big, not 2 times as big. You can only double one of them, not both of them. So if you choose, no, the graph is misleading. The length of a side has doubled, but the area has been multiplied by 4. That's the mistake. Well, this is not a mistake. People who want to promote a product, guys, they don't make it. They know that they're making a big mistake, but the intention is to mislead, just the consumers, the potential consumers. And that's one of those things, guys, just for your information. An honest graph, guys, would have been like this. That would have been good. From four units, 4 small box squares to 8, that's doubled. Okay, let me show you another misleading graph. Those kinds of graphs are very misleading, and I think I will tell you now. Next time you look at the graph, you look for that thing right away, you would know whether the graph is misleading or not. What do you think? Just look here. What do you think is misleading about this? It will change the shape of the graph totally, you know, just and it will project a different picture from the real one once they mislead you right here. Where do you think you were misled here? When we do the axis, what should be this number right here? This is the origin. What should it be usually?
It should be there is the label under each point, like the years.
No, when you do the axis here, the X and Y axis, we call this point the origin. What is the X and the Y of the origin?
0.
0. What is it right here?
10,000.
That's misleading. Once you do, you're going to inflate, you know, just your graph if you don't start at 0. So if the vertical line doesn't start at 0, the graph will be misleading. And it will show you a totally different, you know, just a graph from the real one. It makes a big difference. So anytime, guys, you see a graph that the vertical scale doesn't begin at 0, that's a misleading graph. So try to look for this anytime you look at the graph. Check right away. Does the corner right here start at 0? If it doesn't, be suspicious that the graph is misleading. Just the shape of the graph will change as a result of starting at 10,000. And I'm going to show you how this can be misleading. I'm going to just display this graph. Just give me a second. This is a graph that displays the sales that a salesperson did in 2020 and then in 2021. The salesperson decided to start the graph at 50,000. If a person doesn't look at this, what would be the impression that someone, you know, someone is just looking at the data? What impression would they make right away by looking at the bars? Can you guys tell me? What would be the impression that you make when you look at the bars as far as sales? What happened from 2020 to 2021?
They increased significantly.
But by how much? Would you guys agree that this is almost twice as high as this? So would you guys agree with me that it does appear like the sales, you know, has doubled from the bars? If you get, you know, double the size of the bar, that means the sales has doubled. Okay. But the actual truth, but this is not the truth, guys. Look. The salesperson started the graph at 50,000 and scaled up 55 tick mark, 60,000. So actually the sales were 55,000, but they went up to what? 60,000. Only $5,000 increase. But the graph does not depict that simply because you did not start at 0. So you see how this graph can be very misleading. You want to see the accurate graph if I start at 0? I'm going to show you how that should look like. What do you think now, guys? I'm not misleading you anymore. I'm telling you that the sales were a little bit higher. Look, the bars are a little bit higher, which is 5,000 more, and that's it. And the reason why I was able to do that, because I started at 0. If you start at 0, this is how your graph is going to look like. This is the real one. You don't start at 0, you can convey a different message to people. So I hope, guys, that you are seeing the power of statistics already, what you can do with statistics. I'm not saying that we should misuse, you know, just statistics, but it can be misused. So section 2.3, it's a measures of center. What can we do? How do we find the center of a data set? So you have this data, guys, and you need to find, you know, the center, what happens on average. you find what we call the average. And the average is you add up all the quantities and you divide by the number of quantities. But in statistics, the average is not called the average, it's called the mean. So they call it mean. And actually in statistics, there are 3 averages. One is called the mean, another one is called the median, and the third one is called the mode. And what I'm gonna do today, guys, I'm just gonna define the 3 of them. And the good news is you don't need to do any of the work, by hand. The calculator can handle all of this. You can compute the mean and the median using the calculator. You can do it by hand. It's not difficult at all. But the mode, you have to do it by hand. It's very easy. The mode is the value that occurs most often in the data set. So you just look at the data and you'll be able to see it right away. So why do we need to learn, just about the measures of center? I've just put this statement right here. A graduate teaching assistant students in math was asked to grade 40 final exams selected at random from several large sections of an introductory course. And these are the 40 exams. If the professor wanted to know, just how the class did as a whole, well, if you present the professor with this data, it's going to be very difficult, just to be able to tell, and especially if you have more than 40 students, like 100 students, you're going to have to go through the data from the top to the bottom and see. You won't be able to figure out, just have one idea of how the class is done. So you should be able to summarize the data. And in order to summarize the data, we introduce what we call the measures of center, which we're going to introduce you first of all to the mean. And the mean is right here, is the sum of the observations divided by the number of observations. So one thing the graduate teaching assistant could have done for the professor is to compute the mean of this and tell the professor what the mean was. And then the professor will have very good idea on average how the class did. So that's what we call the mean. This is a sample, guys. And the mean has a notation now. You just need to start getting used to it. We use X bar. This notation is the mean from the sample. And if you have the entire population, guys, and you need to find the mean, there is another notation. This is the notation for the mean. It's mean from population. In real life, guys, we usually don't know the mean of the population because the population is so large that it's very difficult to obtain the mean. But any sample, guys, that you get, you can easily find the mean from the sample. So we have 2 notation. X bar is the mean from the sample. They call it the sample mean. And this is called the mu. This is how you pronounce it. It's a Greek letter. It's to denote, just population mean. My question to you guys, before I do the example and show you how to find the mean. The following are salaries for 4 randomly selected employees at Microsoft. Calculate the mean. Would the symbol for this example be X bar or will be the second one, mu? What would you say?
X bar.
Yeah, X bar, because it's a sample. You know that there are more than 4 employees at Microsoft. If Microsoft had only 4 employees, that's it, that will be the population. But that's not true. So that's an X bar. So just do it like this. I'm going to do it by hand, but I'm going to show you how technology can do it in a second. And divide by the number of observations. And let's see what this one is. So this is doing it the traditional way of doing things, guys, which you really don't need to do it this way, but just give me a second and then I'm going to introduce another way. and then divide by 4. Okay, I got 133,625. So this is one way to find the mean, but let's show you now the power of the calculator, that you don't need to do this add and divide. Calculator knows how to do it without doing this. So watch. Okay, let me show you. First of all, you have to input the data. So the calculator needs to know what the data is. Otherwise, there's nothing it can do. So how do you input data using your TI-84? You just press the stat key. And I already have a 3-minute video, guys, that shows how to do this stuff. So that will make it, I'll make it available separately to you. You don't need to watch the whole video to know this. So stat, and then you press edit. And just like Excel, there are lists where you input. So I'm going to just clear this, assuming that there is nothing there. So just make it. Okay, I'm going to go back to L1. By default, you're going to see this. Input your data in L1. Just start typing 130,000 and press enter. At the bottom right corner, oh, I put 13,000. That would have been a trouble here. $135,000. 133,500. And what was the last one? 136,000. Once you do that, now I'm ready to show you how the calculator can find the mean for us. You quit. This is how you quit on your calculator. Second, and quit. Anything that is marked in blue, you have to press the second key before you execute that. And now you go to stat one more time. And not edit, you already put the data. Just go to calc, press enter, and confirm that your list is L1. I put my data in L1. Don't do anything for frequency list, just hit calculate. And guys, you're gonna see the first value is the mean that you're asking for. There you go. It's 133,625. It gave me a lot of other stuff that we will discuss later, but what I need now is just the first value, which is 133,625.
Professor, could you show how you got to this page again?
Yeah, sure. Okay, first of all, let me show you how we put the data. So stat, edit, and start entering your data here using the keys on the calculator. And then quit. Here's how you quit. Then here's how you do it. Stat one more time. Watch. Edit. Sorry, not edit. We're done. Calc with the right arrow key, guys. And just enter and follow directions. Don't do nothing. Just scroll to calculate. And when you scroll down with those keys, so these are critical keys that very important keys that you have to use, and just hit enter. It gave me a lot more than what I bargained for, but we will learn about this stuff later. Actually, this is the main thing that we do in chapter 2. That's the most important feature right here, stat and then calc. So the mean is 133,625. What's the median? The median is the value in the middle of the data set after you arrange the data in order. So in order to find the median, guys, of this data set, you will have to arrange the data in order. So I got the smallest value is 130,000. The next one will be 133,500. The next one will be 135,000 and 136,000. Okay. The median is the value in the middle. Let's see what the middle is. This is what I tell students to find the middle if you want to just do some hands out. Cross one number off from the right, from the left. Right, left. Well, the median has to be here. This is the middle. Okay, well, what is
So
this
add the
value,
two.
guys?
So we're gonna add the 2 and divide them by 2, right?
Yeah, exactly. That's the only way. But guys, good news, you don't have to actually do any of this. I mean, it's faster to do it by hand than using the calculator, but let me just show you.
134, 250.
That's the median. Exactly. Well, the median is already done for you guys. Let me show you.
Then if we have a number in the middle, that's mean the median, right? If it was an
Yeah,
odd number.
if it turns out that to be an odd number of values, you're right. I'm gonna show you that. So, okay. Well, let me show you where the see the arrow here is telling you scroll down. So just go here, and here is the median, MED, 134,250. Done. Do you guys know what this value is? The MIN, what does it stand for? Minimum.
Value.
Minimum. That's a small. And n equals 4 means how many values do I have in the data set? I have 4 values. And look, the median is done for you, 134,250. If you have an even number of values, you are correct. The median is going to fall between 2 values where you have to add them and divide by 2. But if you have an odd number of observations, the median is going to be one of those values. So let's give you another example here. All right. Let me just go to the next page. Okay. But before we do that, let me just do this for the median. Let me put some odd number of values here. Okay, what do you think the median is going to be? I did arrange the data in order for your convenience. Do you guys agree with me? It's going to be
21.
21.
Yeah. Okay. One time I asked my students the following questions. You have 47 values. Observations. Where would be the location of the median? Can you guys tell me? What was the location of the median here? Let's count. First, second, third, fourth position. And if you count this way, guys, it's going to be first, second, third, the fourth position. You have 7 observations here. Well, actually, if you have 47 observations, and I give you 4 choices, where would your median be located? In what position?
24.
24th, yeah.
How did you know that?
I divided the 47
That
by
one, exactly. So here's how you figure it out. Very good. 47, you add, if it is odd, add 1 to it, it will be 48 divided by 2 will be 24th. Just count to the 24th position, but make sure your data is arranged in order. That will be your median. What about if you have an even number of values? Let's say you have 50 values. Where would the median be located? It's not going to be one, probably it will be one of those values, but it's going to be in the middle between the 2 of them. So what would you do here?
25 and 26.
25,
25
26.
and 26, exactly. It's halfway between. And this language, guys, I already touched on it right here. I put it in there. Okay, mode. Mode is the value that occurs most frequently in a data set. You can have more than one mode. And when no value is repeated, we say that there is no mode. Calculator doesn't do the mode for you guys because it's so easy. Nobody bothered to program, just a calculator to figure out the mode. So what would be the mode in this example?
84.
84 repeats three
Three
times. I
times.
agree.
84, 82, and 86.
But
No,
82
82.
repeats only 2 times. So the mode is the one that occurs most frequently. Since 84 occurs 3 times more than the others, so it's going to be just 84. But if you have 84 repeats 3 times and 82 repeats 3 times, then you'll have 2 modes, 84 and 82. Okay. Now we're going to fill in the blanks, guys, here. What type of data, guys? We only can compute the mode. We cannot compute mean and median for it. You learned that yesterday and before yesterday. What type of data? It's not possible to find the mean and the median for it.
Quantitative and quality.
You mean qualitative data?
Yeah.
So for example, guys, if I ask you, what's your favorite color? And you list colors for me. If I see like people pick black as their most favorite, then the mode will be black. You can do that, just as a qualitative. But I cannot ask you to find the mean and the median of the color, because these are not numbers. I need numbers. So for qualitative data, the mode is the only one of the 3 that makes sense. And I think, guys, you should agree with me, for quantitative data, mean or mode is often preferred over the mode as a measure of center, because the value that occurs most frequently might not necessarily be located near the center of the data set. And I'm going to give you an example why the mode should not be used very much, guys. Watch. Okay, what's the mode of this data set?
100.
Do you guys agree with me that the 100 does not represent this data set, because most of the values are what?
1 digit.
1 digit. So it's not necessarily that the mode is a good representative of the data set. So we should refrain from using, the mode to represent a data set. But people, when they want to mislead others, they can use it and they say this is an average, and they won't tell you which average they use. They end up using the mode without even telling you that the mode has been used. So this is the power of statistics here. So that's an example where the mode is not a good representative of the data set. It's better to use median or mean. All right. Now I'm going to give you this, my favorite example. Which one do we use, the mean or the median? We said we can use the mean or the median, but now you're going to help me decide. I'm going to give you a scenario, guys, and you're going to tell me which is better to use, a good representative of the data set, the mean or the median. So let me just prepare this example 1 second. So let's say we have a neighborhood, a section of a street that has 6 homes built in there. And these are the values of the homes. So one home is worth $75,000. Another one is worth $80,000, $77,000, $73,000, $70,000. And then someone has a triple lot there, build a very nice home that is worth $950,000. I'm sure, guys, you've seen neighborhoods like that, standard average homes, and all of a sudden you see a home that stands out on a triple lot, 5,000 square feet, it's going to be worth, you know, just a lot of money. So let's find the mean and the median for this one. So just to make it easier on us, we're going to put data in L1 and just try to figure it out this way. So I can show you how to use the calculator one more time. So you go to Stat, Edit. Okay. If you guys want to clear the list, guys, look what you can do. Just go up to L1 and hit clear. And here is the clear button right there. And enter. And my data is clear. You can type over it, but it's good to clear it better. So 75,000, 80,000, 77,000, 73,000, 70,000, and 950,000. Okay. Go to Stat, Calc, one variable statistics, and just hit calculate, and I got what I want. So I got X bar, it's $220,833. That's the mean. And the median, guys, is the value in the middle. So since I have 6 values, it's going to be between 2 values. Let me show you what the median turned out, 76,000. Okay. Remember, this is an average and this is an average. This average is called the mean and this average is called the median. Okay. This guy wants to sell his home right here. He hired a real estate agent that knows a little bit about statistics. So this real estate agent will make the following advertisement. He will say, you're getting a bargain. We're selling this house for $73,000 in a neighborhood where the average price of a house is $220,000. Well, when someone tells me that the average price of a home in this neighborhood is $220,000 and I'm getting a bargain for $73,000, I think a lot of people, you know, just are gonna go for it and they're just gonna try to take advantage of this opportunity. So do you know what's been happening here? This realtor knows that in statistics, there is more than one average. There are several averages. So what kind of average, you know, just a realtor is using to advertise the house?
Median.
Not the median. He says the average price of a house in this neighborhood is $220,800. So he's using what?
Yeah,
The mean.
yeah, but I think it's not true. That's why I'm saying the median is better.
Yeah, the median is better, but the realtor was careful. He didn't say the mean is, he says the average. You don't know which average he's talking about. It could be the mean, it could be the median, it could be the mode. Let's rule out the mode anyway. But do you think it is ethical, you know, just for the even a realtor, you know, just to use the mean here to advertise, you know, that they're selling a house for $73,000, but he's saying that the average in this neighborhood, and he's not wrong. The average is $220,833 when you refer the mean. But as far as work ethics, guys, that's not ethical to do that. You cannot use the mean. That's wrong. Morally, it's not right, you know, just to use the mean. And do you guys know why this guy should not be using the mean? What's the reason? Look at the data set.
The reason is there's five houses like close to each other with prices, and there's only one house with $950,000, which makes the other houses look smart.
Exactly. So guys, remember this in statistics. When your data set has some values that you feel don't belong there, You should not be using the mean, you should be using the median. And let's make it make sense now. If the realtor, instead of saying the average price of the house in the neighborhood is 221,000, if he said the average price of the house in this neighborhood is about 76,000 and you're getting 73,000, would that be a reasonable statement? Yes, that's the price and you're paying the price, the average price, but don't mislead people. This value, guys, is called an outlier. An outlier is a value that is far removed from the data set. It doesn't belong there. And when you suspect that there is an outlier in a data set, guys, you should refrain from using the mean. You should use the median as a measure of center, because the mean will not be a good representative in this case. This value could be on the very large side or it could be on the very low side. Either way, it's called an outlier or an extreme value. And you know, guys, an extreme doesn't have to be on the larger side. It could be also on the other side as well. So this is an example for you guys to know when you should use the mean and when you should use the median. And actually, there was a question on my final exam. I asked students to find the mean and the median, and I asked them which one is a better measure of center. If you suspect that there are outliers in the data set, you should tell me that the median is a better measure of center in this case. Okay. So I hope that this example will give you an idea of how to distinguish between the mean and the median and which one to use. So now I can fill in the blanks here. If there are outliers in the data, the median is preferred over the mean, as the mean can be misleading when outliers are present. If there are no outliers, guys, the mean is the preferred method. The mean is often the preferred choice because it has some nice properties which will be important in making inferences later in the course. Actually, your course is all about the mean. So the mean is very, very important to us, but not when we have outliers. The mode, guys, I wouldn't just even bother much with it. It's not a good representative most of the time of the data set, unless if it happens to be right in the middle of the data set. Any questions? Okay, what I would like to do, guys, and which actually I omitted, just this section from your book, the weighted mean, but I would like you to know how I compute your grade. So it's important to understand the weight of weighted mean just for the sake, just of knowing how your grade is computed. In the syllabus, I said 20% final exam, 12% homework, 5% project, etc. So how do I compute, just the final grade? I'm just going to give you an example on how to do that. This is called weighted mean. In this class, your grade is determined from the following sources. So 20% exam 1, 20% exam 2, 25% exam final. That's not your syllabus, just making this up. 15% from lab, from homework, 5% from project. If you end up with the following scores, what's your average? So I think these are the weights. Actually, I made a mistake here. So 20, 25%. And then should be homework 20%. And project is 15%. That should give me what, guys? Everything, yeah. And there is no lab. Okay. How do I compute the score? Look, how do I compute your final score? Well, I don't do it by hand. It's all automatically done. Since your exam 1 is weighted 20%, you just take only 20% of your exam 1 score. So you do 0.2, guys, times 84, which is going to be 16.8. since your exam 2 is weighted 20%, you just do 20% of your exam 2 score, which is 15. Your final exam is weighted 25%, you just do 25% of 72, which is 18. Just multiply them on the calculator. Your homework is 20%, so you just do 20% of your homework score, which is 120 times 100. And your project is 15%, you just do 15% of 85. And what do I do with those numbers, guys, to figure out your final grade? Any suggestion? Adam? So it will be 16.8 plus 15 plus 18 plus 20 plus 12.75. Let's see what this one is.
82.55.
82.55.
0.55.
Okay, you earned a B. That's how the system does that, and this is what the weighted average is. It's good to know how weighted average works. All right. This is in your book. I just put it in my handout. Just didn't want to recreate this one. I'm going to show you the shapes of the different histograms, and I want you to bring your attention to one shape, which is going to be the prevailing shape throughout the remaining 6 weeks of the semester after today's lesson. Okay. This is a histogram, guys. Look at it. They call it a symmetric distribution of the data. This is your data. We did a frequency table and used the frequency table to do a histogram, and it turns out to be like this. If I ask you guys to tell me what's the mode of this data set, will you be able to tell me what the mode is? I'm gonna hide this. How would you figure out the mode? The mode is the value that occurs most often. From the graph, how can you tell what the mode is? What do you think?
The tallest box.
The tallest, exactly. Okay, the tallest bar. And what's the value under the tallest bar, guys? I don't know if you can see it. It's between 7 and 9. It's right here, 8. The mode is 8, guys. But since this is a symmetric graph, guys, you can see, if you think of the tallest bar as the mirror, whatever you have on the right, I see a reflection to it on the left. In this case, guys, the mean and the median are going to be exactly the same, and they're going to be exactly the same as the mode. So actually, the mean and the median and the mode in a symmetric graph are exactly the same. They are all 8. All right. This is called symmetric distribution, and it has actually another name. They call it bell-shaped distribution, and let me tell you why we call it bell-shaped. Watch. It looks like a bell-shaped curve. That's a very, very important distribution. And probably this, what I'm going to say, it's going to take you by surprise, but most of the data that we collect in real life from people and we try to graph it using a histogram, it will turn out to be a bell-shaped distribution or a symmetric. Because we are all humans, we share a lot of characteristics. So it turns out that most of us will turn out to be right here in the middle. A few of us are on the extreme side from the right, and there are a few of us who are on the extreme side from the left. And this graph represents most data that we collect in real life. That's why I told you it's a very, very important graph. The second one, it's called uniform. That means all the numbers are repeating the same number of times. Look, 1 repeats 20 times, 2 repeats 20 times, 3 repeats 20 times. This is called a uniform graph. There is no mode here because everything is repeating the same number of times. So we say that there is no mode. There is no one value that prevails over the other. And the mean and the median, guys, will be again in the middle right here. Can you guys think of an experiment? If you do it like hundreds of times, it's going to give you the same, it will give you something that is uniform, results like uniform, something that we use to play games with. If you do it several hundreds of times, it's going to turn out that you're going to get a graph like this. Can you think of an experiment? If I toss a quarter, guys, 400 times, what do you expect to show face up?
Either heads or tails.
200 heads and 200 what? Tails. I mean, it's not going to be exactly 200, but that's the expectation. If you do it, you know, just with a fair, you know, just a quarter, there will be 200, 200. That's another example of uniform. If I roll a die, guys, if I roll a die, $600 times, what would you expect to show face up? What are the outcomes? What do you think? I'm doing it 600 times. I meant 600 for a reason. What would the graph look like? How many times you're going to get a 1? How many times you're going to get a 2? How many times you're going to get a 3? It's going to be 100 times each because they all have the same chance of being, so it will be something like this. It's not going to be exactly 100, which I'm going to show it to you in a second. But it will be something like that. And that's 100 here. That's another example of a uniform distribution. And talking about this, guys, let's have, so let me just repeat what I said here. So for skewed left distribution, there is a tail toward the left. And it happens that the mean will always be closest to the tail. And then it turns out because it's closest to the tail, it's on the left, it's going to be smaller than the median. When we have a right skewed distribution, as I said, the mean will always be toward the tail. So the mean is going to be larger than the median always. And here is a note here. The mean will always fall in the direction in which the distribution is skewed. For instance, when a distribution is skewed left, the mean is to the left of the median. And when it is skewed right, the mean is to the right of the median. This is very important. That one is not important to us. These two do show up, you know, just as well, but that would be the most important distribution, guys, that you need to be aware of. Skewed left and skewed right distribution. And let me show you an example that I put on the final exam about this section. Here's the example that I put. So I'm not going to put the same question on the final now. Here's what students had. They had this distribution. Okay. Let me tell you can you guys guess what the question was? Any guesses what the question was?
Like which one is bigger, the mean or the median?
Which one is the mean, which one is the median, and which one is the mode? And I tell students always start with the mode because that's the easiest, it's the highest. So which one of those, B or A or C, is going to be the mode, guys?
B.
B, because it's the tallest. Exactly. Then I'll tell students, since you know that this is a right square distribution, you know the mean is going to follow the tail. So figure out what the mean is next. Which one
A.
is the mean?
A.
No, the mean is always closer to the tail. So which one is, this is the tail. Which one is closer, C or A?
C.
C.
C. So then C must be the median, the mean. And now, guys, you know that you have no choice but median to be A. If you have a symmetric distribution, you cannot distinguish between the three. They are the same. But if you have a skewed right or left, you see here, mean is bigger than median. And you know, on the number line, we go from left to right, larger. That's a 0, let's say, for example, here. And we're going this way. All right.